Hello guys, so welcome back to our labs. This is lab 9. In this lab, we're gonna start by the IV characteristics of the BJT transistor, in which you have basically two studies here, or two relations: the relation between IC and VBE, and the relation between IC and VCE at constant VBE, of course. So let's start by the easier one, which is IC versus VBE. I'm sorry. So we should do in that experiment that we should change VBE gradually and record the IC at each change in VBE. Then draw, of course, the characteristics. So basically, we need parameter sweep. So let's do it. Here is the parameter sweep in simulate, analysis and simulation. We're gonna choose basically the first source here, VBE, and we're gonna change it based on the manual here, based from 0 to 2 with a step of 0.05. Okay. For the output, basically the output should be IC. So a good way to do it is put the probe here, the current probe. Okay. It's not necessary, but if you put the current probe, it will appear automatically here in the output variable. So it will make your time short, we can say. Okay. Now we should hit run. And we should see it's not appearing, so we should maximize here. And we should hit run like this. And here it is. So here is, the characteristics. Let's explore it, export it to Excel to have more insight about it. I'm gonna wait for yes. Okay, here it is. This is basically VBE. And here is basically IC. Let's change the names. IC. Okay. Then we then we hit Shift, Control, and the down arrow to choose all the data here there. Insert. And here it is, IC versus VBE. It's a diode relation, It will become more apparent if I just draw it to 1, for example. But anyways, it's exponential relation between the IC and VBE. Okay, we explored it or studied it in the lecture, but it's good, of course, to see it. Let's now check at which voltage VBE started or the transistor started to conduct. So if we consider this point in here, the point at which I put the cursor or the arrow, it's 0.7 exactly. Okay. After which, the current starts to build up. Good. Then I want you to just copy and paste this figure and put it here. Let's exit this screen and put it here basically in the output window. Okay. That's basically for the first characteristic between IC and VBE. Let's do now, the IC versus VCE. Okay. So if you guys remember this relation, is dependent somehow on VBE. How is that? So if VBE, for example, is, let's say 0.1, you will have a curve. If we increase VBE to 0.2, then you will have another curve higher than the first one, and so on. So we need, to change both, basically, VBE and VCE. Basically, the two sources here. Remember, VBE is connected directly between the base and the emitter. So basically, this source voltage is equal to VBE all the time. And this source here, which I call VCC, is again connected directly between C, the collector, and the emitter. So it's equal also to VCE all the time. Okay. So let's again do the parameter sweep. Now we need the two sources. We need the IB and VCE. So we need VCE here. We're gonna change it from 0 to 15 with a step of 0.05. Then we're gonna use the other source, which is basically VBE. We don't have other sources. And we're gonna start it from 0.7 to 0.8 to the step of 0.05. Okay. As the output still I see, which is the probe. If you put the probe, it will make your time, or you make your life very easy. Okay. Maximize again. And try to get run. Yes, here it is. Okay. This is basically at VBE is equal. So this is relation at VBE is equal to 0.7, in which is the current as we just saw, one minute ago, was almost very small, almost zero, right? And you guys see it's almost very close to 0 milliampere. Okay. Then we change VBE to by 0.05, so it becomes 0.75. And here is again the relation between IC and VCE. And as we see, it's almost constant with a change in VCE. And finally, when VBE start to go to 0.8, we have another curve for IC versus VCE. Okay. And again, VCE is almost, I'm sorry, IC is almost constant. It's not perfectly constant. It's almost constant. There is a kind of effect, that makes IC to change or increase a little bit with VCE, but we're gonna ignore it for now. Okay, and one note here is that, look, guys, between the green and the sign here, light blue, the change in VBE is 0.05, and again the change of VBE between the light blue and the blue is also 0.05. Also, the current here is almost, let's say, 150 milliamperes. Here is, let's say, 50. So the difference is 100 milliamperes. Also, if we say this is, for example, 0, the difference here is 50. So it's almost double. It's not changing, linearly, we can say. That is because the relation between IC and the VBE is not linear. It's exponential. That's why the more you increase, the rate of the increase in VBE, or the rate of the increase in IC is not linear with VBE. When VBE changes with regular step sizes, for example, 0.05, the increase in IC will be higher, as we increase further. So, for example, here, for a 0.05 change in VBE, the increase was almost 50 milliamperes. For again another increase of 0.05 volt in VBE, then now the increase is 100 milliamperes. Okay, that's because the relation between IC and VBE again is not exponential. I'm sorry, is exponential, not constant, not linear. Okay, guys, then we're gonna again export this to Excel, just to choose all of them. Wait for a minute. Takes time. And here it is. So look, you can just ignore, because basically it draws IC versus VCE 3 times. So this is VCE, this is again VCE, this is again VCE. So you can just, delete all of these guys. So now you have 1 VCE and 3 ICs. So let's do it. So here is VCE. This is the first IC at what? At VBE equal to 0.7. Equal to 0.7. Okay, then let's copy and paste. This is 0.75, and this is basically 0.8. So we can choose Shift, Control, and the down arrow, insert, and here it is. One note here is that look at the the saturation region. So we said that it's VC is 0.2 or something, which is approximate value. And look, so let's say that this point is the start of the active region. Okay, and look, it's 0.15 or 0.14. 49 is 1.15. Here for the orange, 0.05, but it's still contained, well contained below 0.2. Okay, it's a good approximation, the 0.2. Okay, guys. Then of course you copy this guy and put it again in the, let's exit the full screen view, in the, in the placeholder in here. Okay, that was basically for the IV characteristics of the transistor. So in the next video, we're gonna explore the second type of characteristics, which is basically the transfer characteristics between, now this time, BCE and VB. Thank you very much for watching this video, and see you in the next video. Bye.